Okay, looking at 4B, it wants you to find or wants you to show that f of 6 can't be 70 if f of 0 is 20. Now, the key to this question is to recognize that the derivative is between 0 and 7. It's always positive, so that means it's always going up, it's always increasing. So the area is getting, when you go when you the area, when it goes up, the area, you're going to be adding bigger and bigger rectangles. Let's assume that it's 7. So we know that what we're doing, and we found that, I think we did this in the first question, we approximated the area, and we got 40.2. What they want to do is, the question is there any possible way for it to be equal to 70? Now this is a weird question, okay, so just bear with it here. So we got to think it through. Okay, well, if the derivative is between 0 and 7, let's just say it's 7. The antiderivative of 7 is 7x from 0 to 6. So I get f of 6, and I think they tell us f of 0 is 20. Put the 6 in, you get 42 minus 0. F of 6 minus 20. 42 plus 20 is 62. It turns out that the most that f of 6 could ever be is 62. That function is just not going up. It never goes up more than 7. And as a matter of fact, we know it's never even going to be 62 because we can tell by looking at the data that sometimes the derivative isn't going to be 7. But we just made the assumption that it was 7, and we showed that that number 62 is the most that this thing could ever be. Okay.